2021 DSR meeting. A little different circumstances, what we got going on, but that's okay. We'll do some things. Before I get started, I just want to talk a little bit about the challenge accepted thing that we've got going on. The presentation I'm going to do for you today was indeed a challenge. I didn't have everything I needed to build it, but I also still wanted to share this with everybody in the group as well. And I'm doing the 18 Seer heat pump and really excited about it. I'm going to share a lot of information with you today. And, but I also wanted to challenge you. I challenged myself. Katie actually asked me a couple of times, do you really want to do this? Do you have enough? Yeah, I really want to do this. I really want to share this with you because it was a challenge. So my challenge back to you is, those of you who say, you know, I don't have enough to build a presentation, or I can't do a presentation, during these times, it's been different for all of us. We've had to challenge ourselves. So please challenge yourself to get out and do some training. If you don't do it, get out. It don't have to be a big crowd. It really don't. You can, you can talk to 5 or 10 people. It's not a big deal. Okay. Make sure you just, start slow, but challenge yourself. We got to get challenges in these times. So make sure you do that. So now let's talk about my little friend here. He has ruled my life for about the past month and a half, trying to get all this together. But I'm really and truly excited about what we got to offer here. And I'll go over all this today with you. We got a long presentation coming up. I got this about 2 days ago. Don't have anything live and running yet on it. So we're going to do a PowerPoint today, but coming in the near future, Tom and myself, we're going to set these things up much like what you saw with Troy and what he did yesterday. And that way we can go through, do the boards, and do everything that this thing will do. Today, we're going to talk about the theory of it and what it'll do. So let's go ahead and get started with this. Because I didn't have every piece of information that I needed, and there are some last minute changes, I generally don't talk about this slide right here, but I want you to understand there may be some tweaks and changes to some information that we're going to share with you. So just please take this and look at it. And it's not going to be big changes. Don't get me wrong. It might be a hertz change here or there, or a temperature change. That's not going to be a big deal, but it may be a change nonetheless. So let's make sure we understand that. I will get on my soapbox. We tried to find one a little earlier so I could get on and start preaching, but I don't want to do too much on that. But I want to talk about, it is using 410A, and you just went through, and Dave Whittingham talked about regulations and things of that nature. So we are using 410A in this machine that will only come in a heat pump. So one of the first questions I got was, well, what do I do if I'm on AC? Well, you just jump out R to O. That's all you got to do, okay? And we'll talk about all kinds of crazy things this thing can do today, but it's only going to be in a heat pump, but 18 Seer. Now, when we talk about 18 Seer, we're going to start talking about transducers, suction and discharge pressure transducers, which is new for us. That's going to be completely new for us in this market and what we're doing with this. So I'm going to warn you about some pitfalls and things of that nature that we really got to be careful of. We don't want to take this machine and say, I'm going to put it on this coil, and if I set it on a certain setting, it's going to compensate and take care of that. You're not doing this machine justice, or you're not going to do the customer justice as well either. So when we say 18 Seer, nominal Seer, there's a lot that goes into that. I want to make sure we understand that as we go along. It is a variable speed compressor, okay? And there's good algorithms to this. And let's look at the tonnage, okay? I know Jeff Butler talked about a little bit about it yesterday. It's going to be coming 2 SKUs. So in other words, you're going to hear me say 5 ton and 3 ton. But now you can take the 3 ton and turn it into a 2 ton, and you can take the 5 ton and turn it into a 4 ton. So again, let me stop, get on my soapbox for a minute. Make sure when we train on this and you go out and you talk to your contractors, this isn't something we're going to use to say, okay, when it gets hot outside, or I put this thing in the summertime, you're going to be tempted to do this. contractors may be tempted to do this. You know, I got this 3-ton. The house was sized for a 2-ton. You really do need to size it. But the house was sized for a 2-ton. Well, I know it's hot, so here's what I'm going to do. I'm just going to leave it in 3-ton right now. And, you know, I'll cool the house down even more. I'm going to show you later on in this presentation where the hertz changes and all that. That's not going to do you very much good to do that. Plus the fact when you go back into heat, you change all those algorithms as well. So let's make sure we discourage the contractors from going out and saying, I can bump it up in the summertime in the south and then bump it down in the wintertime. And then the exact opposite may happen in the winter. If you go up north and they say, you know what, I can bump it down and bump it back up when I go out and do my preventive maintenance agreements. We don't want to do that, okay? Please size it right and put it in and leave it at the tonnage that it's supposed to be. And then it is a single phase unit. So none of this has changed for a single phase unit. But the great thing is we're going ahead and going to Omniguard. So this has an aluminum coil on the outside of it right here. That's great for corrosion and protection. So those of you who are near the coast and everything else, or any type of area that may have high corrosion, it's going to be already be on there. So you don't have to do that. And the A is, hey, this is the first one we got out. Really important that when you have to go and you have to order parts or anything else, the dash numbers are always important. If you don't tell them the dash number and the revision number, there can be a parts change, a compressor change. We don't know. But without that number, we got to have it, okay? And let's talk about some of the features that are on here, okay? You can see here, and that's why I've got this sitting here, but you can also see on the screen, you can see the Ecm Fan Motor. Now, there's several different programs this Ecm Fan Motor is going to do, depending upon the tonnage and everything you set it on, and then depending upon what algorithm you're actually going to use when you're running this. So, and if you look, this thing looks and it's kind of laid out a lot like our 20 Seer. So if you, when I show you the differences today, it is a huge difference, night and day difference between all of it. But we do have the same inverter, and I'm going to talk a little bit about the inverter. I'm not going to get too deep into it, but I will talk about it. Pressure switches and transducers. Transducers is going to be huge for us, and especially when I'm getting into the numbers and everything else that, you know, what is it going to do? How is it going to react to this certain situation or that certain situation? It's going to be different. The main controls, it looks a lot like a 20 Seer, but it is not. So when you look at this, and I've got some good pictures of it coming up, make sure you don't mistake it for that. Compressor. We're using 2 different compressors on this, okay? So on the 2 and 3 ton, we're using a rotary compressor. On the 4 and the 5 ton, we're using a scroll compressor. Both of them are LGs. Now, the reason for that is because the scroll compressor gave us better efficiency in the 4 and 5, whereas the rotary worked better in the 2 and 3. So again, that's where model numbers and everything really comes in to play there. So we got 2 different compressors. Installation. This is where we really got to be careful. And especially when I do the cutaway of the rotary compressor, you'll kind of see why that is. But on this installation, I'm going to show you some things that are probably redundant to you. You've probably seen it before. But when I show you that and then explain to you why I'm showing you that, it'll make a little bit more sense. So I'm going to share a little bit of past history, knowledge, and lessons learned from the past of what we've done. Excuse me. So let's look at these lines on here. And I want to really go through. I don't generally like to read screens, but I'm going to have to on this to make sure you understand what sizes these are. Because you know as well as I do, you're going to get that phone call. Can I leave this line set the same size? Can I leave it 3/8 and 3/4? How much difference is it really going to make? What's it going to do to my system? If I bump it down from a 3 to a 2 ton, does it matter? Et cetera, et cetera. Okay, so you can see the 2 and the 3 ton have 3/4 inch suction lines, and the 4 ton has 7/8 on there, and then 1 1/8 inches on the 5 ton. Now, the 1 1/8 inches seems to be a little bit of a heartache sometimes, but then when we start talking about suction risers and things of that nature, it's really going to be important that we get all this correct. So that's just for 50 linear feet as well too. So if you look at that, this is for 50 feet. The unit comes charged for 15 feet. But this is the basic of what we got right here. Now, is there some situations where we're going to be asked, and let me go ahead and give you a scenario right now. Let's look at a 5-ton. They're going to say, I got a 5-ton, it's a 7/8 inch vapor line, but I'm only running 20 feet. Do I really need to change that? Well, the Allied answer is yes. But if we look at some different programmings with pressure drops and things of that nature, and if it's in, cement or anything like that, or a wall we can't tear up, or if you got a historic home, you can't tear into the wall. We got a lot of them around here. We may need to finagle a few things, but we got to make sure we really check that really well. So let's look at this slide pretty good bit here too. We got our tonnages over here, and then we got our total length, and then we got our maximum linear length as well too. And you'll see in the past, we normally went ahead and said 50 feet, and that's all you can go. But here, if you look, we got 150 linear feet, but we also have a maximum vapor rise and a maximum liquid rise. So if we're pushing this thing to the limit, we want to make sure that we got the correct line sizes, correct line sets on there. And then you'll look at the very end over here where it says vapor riser size. If you don't have a good program to run this, you probably need to go ahead and get one. I'm going to show you the one I use in a few moments. But if you don't have one, you need to get one because it's going to be imperative. Because I'm going to start talking about oil return algorithms and all this kind of stuff on here, and it's going to make a lot of difference as to how this thing runs. And remember, this is not a 20 Seer. Take that and flush it out your head. Okay. So let's look at some of the linear lengths, and the shaded rows are going to indicate your liquid line size of what you need. So for a 2-ton, we're looking at a 3/8. And if you look at all of them, it's all 3/8, which is nice. Again, we're going to get those questions of if I have a short run in the north when you got a unit and then you run straight into the basement and you drop down, we're going to get a lot of questions on that. And I realize that. If we can change that, please change it. Y'all know that's the answer. It's not always an answer that's very popular, but it is an answer. And we want to make sure we try to stay away from 1/2 inch unless we start going up in our risers and doing things like that. And we can show you that, and we'll have more charts. We're coming out with a service manual on this as well that has this type of information in it. You can actually look at it, plot what you need to do, lay out your line sets, lay out your suction risers, and in the end, you're going to be much better off for it. So here's an example. This is the program that I use, but here is an example of what's going to happen in that system. And let's take our time and go through this because it's really going to be important. So I put a 3-ton in here. The reason I put the 3-ton in here, this is a rotary compressor. So on that 3-ton, if you look, I put 100 feet with a 40-foot vertical rise in here. That's stretching it pretty good. I'm stretching it out. And then I put a 7/8 inch suction line on here. So for this length and this rise, there's a couple of important things we need to make sure of. Now, I'm only interested in suction velocity, total suction pressure drop, and liquid line velocity as well too. And liquid line drop as well, but these boxes will turn red if something goes wrong. So if we run into one of these situations where we've got to look at a specific installation, we need to make sure it contact service. They have this same thing. A lot of you guys already have a particular program that does this. Use it and look at it. And if you have to, screen capture it, send it to tech service, and they can say, okay, yes or no. Okay. But this is one that's, okay, we're 100 feet, 40-foot vertical. Yes, you can run this line set on this. No worries, no issues. The problem comes in is if we change our suction line or vapor line, if you will, down to 3/4. That's the reason why I chose this side. The reason why I chose this size is because you're going to see 3/8, 3/4 for 3-ton applications all the time. And it's going to be really tempting to use that 3/8 and 3/4. But if you have to go this long way, you cannot use 3/4. We're looking at a 5.51 pressure drop on our suction line. Now, liquid line velocity stayed the same. Reason being, we kept the same diameter, but that velocity on the suction pressure, that's not going to work. I will refer back to this slide sometime during this program several times. So remember that, because when we get into the algorithms and the timing and everything, we don't want locked up compressors. So I'm going to share a little story with you right here. We had some lessons we had to learn with rotary compressors a few years back. And one of the lessons was, if you don't put nitrogen through these systems correctly, then you may have some issues or problems. Even if you keep the valves closed off, and you solder everything else in or braze everything else in, if you don't use nitrogen, some of that carbon can come back and get in that compressor. If it gets in that compressor and it gets hung up inside that pumping mechanism, it can lock up on you. So where a lot of guys they're going to be in a hurry. I'm guilty of it just as much as anybody else. I was young once, believe it or not, I was. And I would take shortcuts. I'm ready to go home. I got a cold beer in the refrigerator. I don't want to be out here all night long doing this. Just braze it up, let the gas go, cut it on, to the house I go. Not always a good thing in here. So this is actually, I got the instructions last week, and this is in the instructions. And please make sure you tell everyone. And I know some contractors are going to they may or may not get insulted. I don't know. But we're all human. We all get tempted not to do this. So nitrogen, and then leak test this thing. Now you can put a smidge of 410A in here. And one of my favorite words of all time, de minimis. So you can let that nitrogen go with that little bit of 410A in here, and you're not going to kill the ozone. We done fixed that. So don't worry about the ozone with this. And but you do want to leak test it, and you want to push this thing to the utter limits. You do not want it leaking out on you. And later on today, Tom and myself, we're going to step over here to the side. You can't see it right now, but we're going to step over to the side. We're going to do some tear downs. And you may notice the valves that are on this unit. And we're going to talk about these valves. These are nice service valves, and we decided to go ahead and implement them on this particular model as well. So really good. Looking forward to that. Looking forward to your feedback on that, making sure. So when we leak test, there's also another way to leak test as well too. We got to pull a good vacuum. 500 microns, sustained microns, okay? You don't, I mean, if it takes 12 minutes and it goes up to 600 or 700 microns, we're okay. Pull it back down. It's no issue with trying to triple evacuate a system. But if you pull this thing in a vacuum and it just jumps right up and climbs right up, you got a leak somewhere. You need to go ahead and take care of it now. Remember, and I'm going to say this a bunch, by the time I'm done with this presentation, someone's going to reach through that camera and slap me and go, if you say transducer one more time, I'm going to beat the fool out of you. I understand that, but it's different. Okay. Make sure even lower than 500. If you got the time, if you can plan your job right and get everything brazed in, go ahead and let me pull in a vacuum while you finish wiring it up. Although it's not going to take very long to wire this thing up either. So when we go with that, you'll be okay. This is something that we've kept for a long, long time. It's nothing new. It's nothing different. 3 ounces per 5 foot, or 0.6 ounces for every foot. So in a lot of these stickers, there's a cover, and I like the way Tom said, there's a lot of real estate. It looks like a NASCAR. You got plenty of room to put stickers and everything on there. A lot of this is actually the labels that I pulled. I got the drawings of the labels. These labels will be on the actual unit itself. So when you pull the panel off right here and you got it in your hands, it'll all be right. There's a ton of information there. It even has some codes, and we'll talk about the codes today as well too. But good basic information. I always say, just remember, these type of things right here are tested in a lab, okay? So when you look at these are good rules of thumb. This will get you close. But if you live by this exactly and don't weigh your charge in, because on this, I'm going to weigh my charge in. I'm going to be a little bit stubborn, a little bit hard-headed on this. And let's weigh it in. I'm going to try not to cuss today, do my best. But let's weigh it in. So if I'm at cooling operation, you'll see this 60, 65. There's going to be a pressure chart I'm going to show you a little bit later on. We start getting a little deeper into this. But that's the sweet spot right up in here. So let's look at cooling operation at 65. 143 suction and 230 head. That's if and depending upon which mode you got it into. Remember this, okay? Because we got 3 different modes we can put this in. I'm going to go over that. So this is in the efficiency mode right here, because this is how this unit's going to come shipped. That jumper is going to be on this board and it's going to be in efficiency, okay? So remember that. So I'm going to repeat that again, okay? So you'll all understand, and I don't want nobody to forget it. This unit comes in the efficiency mode, and these are the pressures you're going to be running, because you can put it in different modes and it's going to run different suction pressures, okay? So that's why they're not on here. If you go ahead and put it in the other 2 modes, it's either going to run 125 or 135 suction pressure on this. No need to put that on there. We know what the transducer is going to try to make the unit run at, but this is what it should be. And don't get upset if it's a little off. If we're at 65 degrees, but it's hot in the house, you may have a little bit higher suction pressure than normal. Don't sweat that right now. Just let it run, let it equalize, let it kind of even out. Let your expansion valves kind of get into their rhythm and get to steady state. Steady state's really important on this as well too. And then you see the 3-ton chart as well. And so the 2 and the 3-ton, that is the rotary compressor in here. So this is going to be on that panel. And so you look at also, this is going to be on the panel too. And look at the indoor matchup. This is not everything it matches up with. This is the most common matches. And this is what you're going to get your best efficiency with when you match it up with these, okay? So you can put it on the BCE 5, the BCE 7. You see your coils there. Quite a lot of matches. But you also see your subcool numbers of what you should be running. So when you weigh it in, yes, you should be running around these subcools. But then you see an add and remove. So if you're at 15 exact feet, you may have to take out some refrigerant. You could take out 1 pound, 4 ounces on some of this stuff. Really important, because you don't want to have nuisance pressure switch trips. This board is a 5-strike lockout board on pressure switch, not on other codes. It's a 10 switch, or it goes out 10 times in 1 hour. That's a different code. We'll go over that. Pressure switch is still the 5-strike lockout rule. That's going to happen. So when they put these things in, you want to make sure if they use a particular coil, they got to take out. In some cases, I'm looking at an EH1P, it's 10 ounces you got to take out. That's what we call daggum near a pound, you know? So make sure we do it. And then the 3-ton over here, you still got to take out quite a bit. A little something new in there that we have on these tags of taking this out, but it's important that we put this on here for you. It's important that you understand and adhere to them, because if you don't, that mild weather when it hits, and this is again, I'm gonna say transducer, you can't rely on the transducer to correct an incorrect charge system. That's not what it's for. Okay, so please don't do that. So on the 4 and the 5-ton mode, again, this is when it's in efficiency. You got to make sure you really know what this tag's saying. Make sure when you work with the contractor and you train the contractor, make sure he knows this, okay? But these charts are great, because when you go to steady state, or you go and you're doing a preventive maintenance and the inside's nice and cool and the outside's about normal for whatever area you're in, then yeah, you should be right around this. Because now's a good time to give a shout out. The engineering team, Krishna, and all the engineering team, y'all have done a fantastic job on engineering this and testing this. And the guys in the lab tech guys, shout outs and kudos to you. You do a lot of work on these things. And I don't think anybody ever really hardly mentions you, but you're the boots on the ground when it comes to this. So thank you for getting us these numbers and helping us to be successful with this as well. And then we look at a little bit more of the matchups and with the BCE5 and what you got to take out, what you got to put in. Again, really look at this. Make sure your subcoolants are right. Make sure you pull out the correct amount and then go from there. Okay. So I want to make sure we went over that. It is a non-communicating system. So here's the question right off the bat. Can I make it communicating? Let me think about that. No, don't do it. Let's ask that question again. Can we make that communicating? No, don't do it. If you try, that board is not flashed with the right program, you're going to have nuisance codes. You might get it to work for 5 or 6 minutes, but I promise you this, you're going to be back at that house and you're going to be taking that thermostat off and putting the right thermostat back on. You're going to see I plus and I minus on this because we use this board throughout Lynx International. This unit is programmed to be a non-communicating unit. So please don't let a contractor look at that and go, I can fix this, watch this, hold my beer. No, don't let them do that. Okay? That's not what we want. So let's look at this wiring diagram after I said that. So we've got a constant torque, variable speed air handler. All right. And now we got a 24 volt non-communicating stat. Well, in this particular case, we can hook Y1 and Y2 up to it. Okay. And it's going to change fan speeds. Unlike what we talk about with the 20 Seer, that's not going to change. The blower motor is not going to change and ramp up and down to go with it. That's not how this works. What it's going to do is when you increase that fan speed to Y2, and then your compressor is going to run a little bit different algorithm, and I'll talk about that in a minute, but let's talk about fan speeds. You only have two, sometimes you only have one. But when you ramp that fan speed up, you're going to raise that suction pressure up. And if you were set to run a certain percentage of that, then that pressure is going to drop back down and go where it needs to go. Again, the transducer is in control of this. We're not doing a fan speed change. We are doing a fan speed change, but it's not going to match the hertz of the compressor at all. Okay. Really important to understand. If you can put a 2-stage stat on this system, you're doing yourself a favor if you can. I know there's some cases where you can't, and we're okay with that. That's just the way it is. But if you're starting from scratch and putting this in and you're able to put a constant torque motor in or a 2-stage system, make sure you do it. Now, if this is a furnace, you got to make sure to cut the links on the board. Now, there's some stuff out there on Allied Air Academy that we went over the old, I don't want to say the old fashioned, but it's not a good way to put it. It's the manual way to do it. So in other words, if you go to an A96 or A97, you got dip switches on that board, but you also have the link W915. You got to cut it for 2-speed. That way you get the 2-speed fan out of it. But then you also got to set your fan speeds. Now, I've only got 2 hours today, and this probably take longer to do everything I want to talk about on this. But you got to make sure your static pressure, you got to make sure your airflow is right, and you got to make sure your CFM is right. If you're going to get everything out of this unit that you can get out of it, you got to make sure all that's right. I did not put that in this presentation today. It will be whenever Tom and I go out and do the classroom version of this, and when we put this out on Allied Air Academy. Make sure to cut this. If you have not done a class because you've been doing Comfort Sync and A3 and you haven't done a class in a while on how to manually set a board up, we've got that. We've got you covered on that. No issues and no worries. We'll take care of that for you. Matter of fact, most of it's already on Allied Air Academy. And that's why, because I've been on the DP team with this Decision Point. I've been on the DP team with this. And whenever I did some of the webinars, I know probably somebody goes, Kyle, with the Comfort Sync and now the A3, why in the world would you even want me to worry about setting this thing up manually? The Comfort Sync does it all. Well, with this, you need to go in and check it and do it, okay? Having said that, remember this, a lot of what I'm talking about today, it goes on behind the scenes. If you could look at what all I'm looking at right now, you're looking at old fat man up here, but there's a lot of stuff out here I'm looking at that's going on behind the scenes, and that's what's going on here. There's a lot going on in this board. So when I talk about this today, don't go, oh, God, it's going to be too hard to put in or not. No. If you know what red, green, yellow, and orange is, you're good to go. You can hook the thermostat up to it with no problem and take off. I want you to know how all this works, okay? So let's go back. You can use a constant torque air handler. You can use a variable speed air handler. As long as it's an AHRI match, make sure you do that. Randy Palm and them do a good job of making sure all the matches go through. They are still working and getting more and more matches out there every day. Just make sure you look, and you can use the tool and all on Ally Connect as well to make sure all the matches are on there. And like I said, I know they're working very hard to get everything on there. Now let's talk about high voltage wiring. Not much. The high voltage wiring is going to come down here, and your thermostat's down here as well too. So your thermostat wire's right here. You're going to hook it up. It has the rasp connector, and you can still pull it off like you did on the old one. So when you look at it, you pull it out, and they got it wire tied right here. You pull them out, you pull that off, and you can wire your thermostat wires up to it, plug it back in, and put it on. When you run your high voltage, there's a lug over here called a ground lug. You may have heard me say ground in any of my classes. Ground. Make sure it's grounded. That's going to be really important to hook that ground up here, because we're going to talk about a little bit of something about what you heard yesterday, power factor correction circuit. Okay. Everything else is already done. We're going to talk about in this board how we're going to do a little bit of setup in just a few moments. Okay. Well, for now, let's talk about how to program this thing, and let's look at what we've got going on here. I was glad of what I saw yesterday. A really good job of showing the board and programming it. The same way you program a 20 Seer is the exact same way you do this, okay? But if you happen to pull one of these things out of the box and it cuts on and you got three red dashes right there, it doesn't have a program from the factory. It should, but things happen. So let's walk through how to actually program this board for the different tonnages. And these are the correct codes over here. 58 is going to be a 2-ton. 60 is going to be a 3. 62 and then 63. Okay. So all that is your codes right there. And when it cuts on, it should show you, it's going to show you the 3-ton code or the 5-ton code. You've got to go back and change it to 4 and 2 if that's what you need. Okay. Make sure to do that. So if you see this, if this happens, we just need to configure it. We just need to go through and program this board. If you see it on a regular basis, please contact Brian Palm and make sure he knows, and we can check and see if anything's happening at the factory where they're not getting programmed. I have heard that sometimes when they go through customs and they go through x-rays, so for some reason or another, the codes get wiped out of them. They reprogram them. Everything's fine. But if we run into a situation where we're seeing that more and more, then we need to worry about getting that taken care of. So we want to enter unit selection code. So we're going to hit it to the dash. And once the dash starts blinking, we're going to push and hold it till it says PU. No, it don't stink. There's my boy looked at this and started laughing at me. Program unit. So the exact same thing what we saw yesterday, but you're going to immediately release the button, and the sequence is going to follow, and we're going to enter the code and the unit combination that matches this. So once we continue to do this, we're going to press and hold that button again. When we press and hold this button again, the unit code is going to be displayed. If you release it, that code is going to stay there for 10 seconds. If you don't hold that button down for 3 seconds, then you're going to lose it, and you've got to go back through this again. Okay. So we have a little bit, I have something written up that's a little bit easier, but also this same exact unit selection code is going to be on the panel that's right here as well too. And so it's going to be there. They don't have to get their phone. They don't have to look it up. They don't have to call anybody. It'll be right there. And even the instructions on how to do it is going to be on the back of that panel, which is a good thing. That keeps you from having to look at it or them having to make a phone call and the frustration sets in. That's what we don't want. But you'll see the button down at the bottom right there, the white button. It's called SW1. And it's configured a little bit different. This board actually physically is a little bit bigger than what the 20 Seer board is. I don't know if it's got more brains in it or what, I don't know. But it's a little bit bigger than that. But the same exact way you program a 20, you program an 18. So for the guys out there who's already used to it, It's not going to be anything different. But what's also good about this, error codes are the same way. Pulling them up is going to be the same way. And, here's what I would suggest with error codes. When you go out and you clean these, we'll talk about coils during the teardown. I don't want to talk about that right now. But when you go out and you do preventive maintenance and you're checking on these things, you really want to go and teach these guys codes. Again, I'm going to go over codes a little bit at the end today, but I don't want to go over every single one. And most of your most common codes, like E600, that's going to be a load shed code. Same thing on other units is it's going to be on this one. It's going to show up, but it's nothing to worry about, okay? It's the other codes that you got to worry about, and they got really great explanations in there of what it is, what we should check, and what could have happened, okay? Make sure when we give these classes and we talk to folks, go over that, give them scenarios, give them real life of what it could be. We've had a variable capacity unit in the field for 6 years now, and Lynx International's had them longer than that. We've got a lot of experience in this. We can lean on that experience to make sure when you read that code, you say, okay, you can even find out if you're in the wrong line set. If you're a DSR and you're sitting in there going, you know what? You're getting the strike code a whole lot on low pressure. What size line sets you run on that thing? If you hear at the other end of the line, you might need to do a job site visit and go check it out. Because if they stutter or stall, and that's fine. I'm not knocking anybody. What I'm saying is when these technicians go out there and they look at these codes, they can see what's going on. They can see a pattern. And if a pattern does form, we can go find out exactly what we need to do to correct that. Okay? Really handy to have. And if we want to exit it, to exit the code, you push the SW1 to the 3 horizontal bars come up, let it go, and you're fine. But now, I also would suggest taking this and clearing the codes out every time that unit is looked at. Okay, it'll hold a ton of codes. And when we look at some codes, it's going to take 10 trips in an hour to actually move a unit to moderate or critical status. Let's make sure we clear those, because I want to know, and then I want to investigate what went on. But when I come to that unit the next time, I want to make sure if that same thing's happening, maybe I missed something, and I don't want to do that. I want to find out what it is, okay? So, the large C and the lowercase c. The lowercase c is the one you clear the codes with. The large C is going to tell you it's in cooling. Same thing with heating. It's going to be a large H. And those designators are on the back of the panel that goes right here as well, okay? So really a lot of good information on that panel and how to do that. Didn't want to go through every single one, but clearing codes is important, and knowing how to program this board and why you want to leave it in the correct mode is really huge to me and everybody else who's going to be working on these. Charge mode jumper. And you're going to see some things on here too that we're going to talk about. And I'm really going to talk a lot about, I can't go but so deep because some of this stuff, we got to make sure that if it's proprietary to us, the patents and all that are on there. But I'm going to get you far enough today where you're going to know exactly how this is going to work, okay? But I can't go but so far with it. When we look at charge mode, and the board's going to come, and what'll happen is the jumper will be just on one pin, not both pins. It'll be on one pin. When you put that into the charge mode, it's going to run your unit at 100% capacity. That way you can charge it, get everything in. Also, if you have a 2-stage unit, it's also going to bring your indoor fan motor up to the Y2 or the highest CFM that it can run. If you happen to leave this on for 60 minutes or more, it ignores this jumper. So it's got a kind of a catch safe in it. This unit is chock full of, what if this happens? Well, this will happen and it'll still run. It's got a lot of that in it. I'm looking forward to getting into that with you today as well. This helps you charge it. This gets it all going for you, and you don't have any issues or any worries because you know you charged at 100%. You know your subcool is right. And a lot of times what I look at is people will go, what about superheat? Do I need to look at superheat? Yeah, you do. Superheat tells you what's going on inside the indoor coil in cooling. You need to know what's going on in both coils to make sure everything's right. Because, by God, we want you to fill out a startup sheet as well, too. And we'll show you one here in just a moment. So the next slide we're going to spend some time on because there was some questions, voice of customer, VOC as we like to call it. There was some voice of customer that came up and said, well, will it handle the humidity in our area? Will it handle the cold in our area? A lot of times our defrost didn't work as good as we thought it should in our area. Well, those are questions I hope I cover and answer today when I go through all this. So let's look at this and let's look at the operation mode. It has 3 different modes: in cooling, 2 in heating. Now in heating, it's not as big of a deal as it is in cooling. We're not trying to dehumidify or anything like that. So let's look, and I got a chart coming up here in just a moment after I talk about this that kind of explains this, what I'm getting ready to say. But the efficiency mode, it has a variable suction pressure set point. So as the outdoor temperature increases, the set point is going to decrease. Really and truly, depending upon your region and what you're doing and what you've got. Let's say you're in Florida and you've got the Gulf Coast and you've got the Atlantic. You still got a lot of humidity, but you got to make sure you understand which one's got the worst. Is Tampa got it more than Daytona? I'll travel there and go find out for you if you want me to. But if it does, you really got to look at the fact that, hey, look at what we can do now. We can change the suction pressure on our indoor coil, which is going to change how cold we can run it, which is going to change the fact that now we can control dew point. That's awesome. That's extremely awesome in my book. So if it comes in the efficiency mode, if you leave it in there, again, I got a chart that's going to show you that. If you put it in normal mode, that transducer is going to try to hit 135 PSI. Here's where the trouble starts. Here's where the temptation is going to be to, okay, I've got an older indoor coil. I'm not sure if my ratio between my outdoor coil to my indoor coil is where it needs to be, but my transducer is going to fix it all. I really want to cuss right here, but I'm not. I'm sure it won't slip out. But no, it won't. It will not do that. That's not what that transducer is intended to do. When you do have a good match system, though, what that transducer will do for you, and we're looking at humid areas right now. If you've got a mild climate or, your humidity's not this extremely horrible and you want to be a little bit more comfortable, put it in the normal mode. Me, myself, I'm always going to suggest the efficiency mode first and then normal. And last but not least, comfort mode, where we're shooting to go to 125 PSI. But we'll talk about low ambient because when we hit low ambient, the suction transducer doesn't take over anymore. It's the discharge transducer that takes over then. Okay, that's going to take over. It is going to run your pressures. So with the amount of flexibility you have right here, with the amount of what you can do, if you stop and think about what power this puts in your hand, it's huge. I can now make this thing run at a certain suction pressure and I can remove humidity. But when I start talking about Y1 and Y2 calls, that becomes important too, because that's going to add to the plate of what we can do. It's going to be great when you get these things, and you'll know your region. You'll work with a really good contractors. You'll work in your regions, and you'll go, hey, look, I know that if I put this in this particular mode in this particular region, it knocks it out of the park every time. Pay attention to what the guys are doing, what they're telling you, and the feedbacks that they're giving you on this, okay? It's going to be great. So efficiency, normal, comfort. Comes factory set for efficiency mode. Yes, there's a lot of numbers on here. Sweet spot, if you'll notice, is between 67 and 62 degrees. And then you're looking at a lot of low ambience going on here. This chart should be and is going to be in the service manual, okay? This is going to be really helpful because 365 is going to be a lot. And you look at these pressures here. Let's look at a 2-ton heat pump in heat operation at 32 degrees outside. 32 degrees is freezing. Everybody, a lot of people who do dual fuel, which this is a great unit to do dual fuel as well, but a lot of people look at 32 to 30 degrees to be a balance point to change over. Well, the discharge transducer is going to be taken over, and it's going to be running this thing right here to make sure it stays at 304 psi. So the transducers are really important, and we're going to get into in a little bit what happens if the transducer goes out, which is another thing that they just knocked out of the ballpark as far as I'm concerned about what it'll do. So you can look at this chart and you can look across it, and this is really going to help you. But low ambient modes, realize 65 is kind of the sweet spot in this chart and this transducers, because you got to give and take a little bit of PSI. That 62 to 67, that's the sweet spot. That's also going to help you whenever they take service calls or you got a contractor that calls up. Make sure to ask them, what was the temperature outside? It's going to be important. And it's not just for our equipment. The way equipment now is becoming where it can do more things. I don't want to say complicated, because really and truly, Troy nailed it on the head yesterday. The more complicated this gets, the easier it gets. Okay. I know that sounds strange, but it truly is. It's really easy. Make sure we get all the information from them. This is an example of a startup sheet. And you notice we got refrigerant type, amps, pressures, all that good stuff. Put that on here. Put on any other information. If you use a program that does startup that has more information, the more information you can put in, the better. Okay? Because you want to make sure you left that running, and you want to make sure you left it running right. And a lot of guys have told me, I know there's several service companies out there, and they use iPads, and they get the customer to sign it. That way you can't come back and say, okay, well, this thing never run right to begin with. Well, you don't want to get into a match with the customer, because they sign our paychecks. But you also want to make sure you're covered and everything's working right, because if something's not working right, now's the time to get it straight. So that's a basic installation. And just remember, it's non-communicating. You can have a two-stage or a single-stage stat. You adjust a few jumpers right here, and that's it. The setup takes you no time at all whatsoever. I think that is a phenomenal for everything that this will do. And I hadn't even scratched the surface yet of what I'm going to talk about, but everything this will do. So let's talk about service. And I'm not talking really about cleaning coils and everything, although we need to. I want to talk about why we should put nitrogen through it, why we should put best practices. But I want to show you a little bit that's going to be different as well for us, especially in this first one right here. We got a suction line dryer going into an accumulator, and then the compressor has an actual accumulator on it itself, 2 and 3 ton only. Okay, because it's a rotary. So we're not using a liquid line dryer. We're not using a liquid line dryer in the rotary compressor. Please don't put one in the line outside as well either. This is a high capacity suction line dryer. It's not like the ones we used to use when we cleaned up systems and they get clogged up real quick. However, checking across them, you shouldn't have no more than a degree drop. If you got any more than that, change it out. But then you need to look at what contaminated that system on the inside. This is where it's important to run the nitrogen through it, because this dryer detects what's going in that accumulator. And this accumulator works just like the ones that's been out forever and ever, amen. It's got the J tube in it. It's got that aspirator hole in the bottom. It's going to pick up that oil and run it back to the compressor. So and yes, they all do come with compressor sound covers. Again, I know that's probably running through some of your head. I want to go ahead and answer that. I don't want to steal our thunder for the teardowns today. So we took the compressor cover off. And if you look down in here, there has been questions. There has been some things. Should I use an accumulator or should I not use an accumulator? You got some people saying, I don't want a heat pump that doesn't have an accumulator in it. You got some people say, I don't care if it's got one in it or not. If it's got a rotary compressor, you need an accumulator. There's no doubt. You're going to need one. In the scroll I'm going to show you in just a minute, you don't. Okay? But for this one, you do. But what I want to emphasize here is also when you have a contractor go out and do a clean and check, we've got these coils raised up. but this accumulator is still bolted to the bottom of this unit. This accumulator is still made out of steel. You really need to take an inspection mirror, run it down there and look and make sure it's not beginning to rust, because the 2 and the 3 ton use PVE oil, which is just as hygroscopic as POE oil. Okay, so there's also 2 different oils these things are using as well. So you want to make sure these visual inspections are done. I don't want to lean one way or another. I'm not an accumulator person unless it's on a rotary. Then I know you need it. Other than that, I don't care if it's got an accumulator on it. But also, what we need to look at as well is the pressure drops that go through it. Okay, so you'll look at the 4 and the 5 ton. It does not have an accumulator on it because it doesn't need it. But I'll talk about that in just a second. A lot of stuff down in here. You got factory high pressure, factory suction pressure transducer, suction line sensor. That suction line sensor monitors superheat, and it also helps as a backup to the transducer. If something happens to the transducer, which we'll talk about in a little bit, well, then that suction line sensor can also help. It's not going to be near as accurate as what the transducer is. Don't get me wrong, nowhere near it, but it will help out quite a bit. A lot of stuff down there. Most of it's color coded. These are all screw on as well too. None of these are welded in there, which makes life easier if you need to replace one. Because every now and again, you're going to have something go wrong. And when we finish putting all this together, we're going to do little small segments. One of the segments we're going to do is we're going to get on this unit and we're going to test transducers. We're going to show you the voltages, the inputs and the outputs of what all it's supposed to do. Again, I've only got 2 hours today. I don't have time to do all that today. And I want to hyper focus on that to make sure we really cover that to where everyone understands it. And when I say we, just think of me and Tom. We're going to do little small video segments so you can watch that, okay? Now, again, these are LG compressors, both all tonnages, okay? But this has a solenoid equalization valve in it. And what it does is it equalizes the pressure between high and low, because you got that accumulator on the side. That's the reason why we also have an accumulator on the side of this thing and we left it on there, because that's going to serve to help equalize this compressor. When this compressor equalizes like this, the chances of needing a hard start kit are going to be next to nothing, okay? That's why this valve's on there. It's going to take care of it, and the control board will take care of that. It knows whenever it shuts off and it's a certain amount of time, it's going to equalize, okay? Really helps on the startup and everything else. And again, the very last thing you see, PVE oil. If you think you have to put oil in one, make sure you don't put POE oil in this. I don't know how it reacts, but I know it ain't supposed to be in there. A nice cutaway of this compressor. So we look at this, and the pumping mechanism's at the bottom. So the rotary compression chamber's at the bottom. This is where, if you don't keep everything clean and any type of carbon or any type of bad buildup of any type of contaminants get in there, they can stand a chance of getting on these this compression chamber and locking it up. So please make sure we understand they've got to clean these out and do a good job of cleaning them out while they're going. Most of y'all seen these slides. I'll go over it again because there's a lot of people who don't know and hadn't used this, but it is a variable compressor. It's got the vacuum protection. That's the biggest thing they run into when they try to pull this thing down in the vacuum. So when they put it in charge mode, here's the scenario. They're going to put it in charge mode. They'll be pumping this thing 100%. They're going to try to pump everything out their core. When it gets to 20 PSI, that little valve on top is going to go, no, you're not doing this. You're not going past this. You're not going to run me out of oil. That's not going to happen, okay? Not going to do it. But it's got the check valve, and this particular unit, this particular compressor, that middle of the shell of that compressor serves as a mini accumulator. So actually, I kind of lied a little bit. That compressor does, it's not a very big one. It's not the capacity you see on a 2 and 3 ton. Don't get me wrong. But it does have a little bit of liquid that it can carry right there. This is the difference why you don't need an accumulator with this one. Now, I know that's an age-old argument, and that's fine. We can go to the bar, sit down, have a drink or 10, and argue about it. I'm glad to, no worries. But with these valves, what happened, y'all see me do this. I'm going to step right here. You got it right there. if there's any liquid, anything that pops back, they're going to pop open. Okay. What happens is as that situation is taken care of, those valves shut back down. Okay. So liquid's not, because this is designed different, liquid's not going to hit and hurt this like it would something else. Okay. Like it would on a rotary being something else. We do have the Gen 2 inverter. So if you remember back in 2015 when we came out with the 20 Seer, we had the big inverter board here, and then we had and you'll see this is not the board we're talking about. These are rectifiers, but it did not have, we had a separate board down here to actually take care of noise and everything else. On 2, 3, 4, and 5, we don't have that. That's what the Gen 2 board is. Okay, you're going to see one board and it has everything on it right there. We still have the contactor, and then we still have the control board up at the top. Nice layout. And again, there's vent holes at the bottom and vent holes at the top. Make sure those are clean. So you got a set of vent holes down here. And then right here beside this board, you got a set of vent holes right here. And what this does, we use the same lesson learned from the 20s here, is when this fan is running, it's going to pull air up through here and out through here, and it's going to cool the front side where your heat sink is taken care of on the back side with the outdoor fan motor running. Okay. Because, and again, when I say hello to my little friend, ladies and gentlemen, this is a 4 and 5 ton unit. And if you look at me compared to this unit, and I got it up on a cart, mind you, so it's sitting, a good 8, 9 inches up off the ground. When this thing's down, this is a 4 or 5 ton unit in an 18 Seer. It's pretty phenomenal. We actually made it like a smaller unit. I mean, it's really great. Again, kudos to engineering for what they've done on this. Really good job. The only reason I put this inverter here is you got capacitors on there. Make sure you wait 3 to 5 minutes, because if you touch them, you will lose your religion. That's a guarantee. I promise you, it's going to hurt. The reason I like the power factor correction circuit, we talked about this other stuff, but what I want to lean on right here is power factor correction circuit. Because I got a field trial 20 at my house, and when the thunderstorms come through pretty bad. So when those thunderstorms came through last summer, first reaction was to go cut all the breakers off so I don't have to fix anything, change anything, protect stuff. I'm like, no, just let it ride. Just let it go. I want to see what happens. Sure as the world, the power was flickering in and out. It was going crazy. The dogs are going crazy. My unit went out on that. Now it reset and everything was fine, because that's the one that takes 10 times before it's actually going to turn into a critical code and then cut completely out. That's one of the most important things on here. That's going to save your bacon more times than not. And that's where that ground is going to come in handy. If you half-ass ground this thing, that circuit's not going to work, and you're going to repeatedly have trips on it, and you're going to be going back. The customer's not going to be satisfied. It's just not going to be a good thing. So a little bit of layout of the board. You'll see the pressure transducer connections. They're a little bit different. They are color coded. I don't know if you can see it here, but your liquid line is going to be red, and then your suction line is going to be white. So red is kind of a color for high, and then white is kind of a cool low color. All right. I guess that's why they did it. I'm just guessing that on the fly. I have no clue. But it makes sense to me. Red high, and then white is your low. And then you've got a set of sensors in here as well too. Okay. So you got your sensors here, your transducers here. Now we go to where your jumpers are on the board. Now I can point to the board here, but if you look at the picture of the slide, this is where you make your adjustments at. Now, if you got big old thick fingers like I got, it gets a little bit difficult sometimes to get in there and do it. I would suggest take a pair of needle nose and do it, but do it gently. You don't want to break the solder on the back of the board. It's built tough, don't get me wrong. But if you go in there with these big claw hoppers and then try to grab it, pull it out, and put it back in, chances are you're going to break something. But there's where they are. Non-communicating. Conventional two-stage stat. Let's talk about this for a little bit. So on a conventional two-stage stat, we're going to require the connections. Again, this is, I don't want to belittle it, but it's almost like a duh to if you've been in the business a long time. R is your power, C is your common, Y1, Y2, O for your reversing valve. Not much to celebrate there, okay? And, Y1 is going to be initiate your Y1 blower, and then the Y1 demand will initiate compressor operation starting speeds, okay? If this thing's been off for a while, we're going to look at starting speeds in just a moment. But if this thing's been off for a while and it's only calling, let's say, for 40% of your starting speed, but it's been off for more than 20 minutes, it's going to start at 70%. It's going to run that way for a little bit because of oil return. Remember I told you we're going to revert back to that slide with the right line sets? That's why that becomes handy. That's why it becomes important. So what happens is, after a minute delay, we're going to bring on the compressor. It's going to reach its target suction pressure. Whether it's in efficiency, normal, it doesn't matter. It knows what it wants to hit at that point. If it's in efficiency, it's going to take that outdoor temperature and then it's going to hit it. If you go to normal, it's going to shoot for 135. If you go to comfort, it's going to be 125. If the thermostat provides a Y2 demand, the indoor blower will increase to its second speed, okay? And then you're gradually going to start raising up on the hertz on the compressor. But what it'll also do after 20 minutes, if you're not at 100%, after 20 minutes, it's going to raise this thing a half a hertz every 15 seconds. Stop and think about that for a moment. What we've just done is we've slowly ramped this thing instead of just slamming on the gas and going wide open and getting this thing to 100% and getting our sensible temperature down real quick. What we've essentially done right here, and we hadn't had to touch anything, we hadn't had to set anything on the stat. What we've essentially done is slowed this thing to get up to where it wants to remove the sensible. And now we're removing latent along the way. That's where it becomes completely awesome on this and how it runs. All this happens without nobody else programming it. Chances are nobody's going to know this even happens in the background. Okay. But I want you to know it, and your contractors need to know it. But this is programming already from us. You don't have to touch this. So if the Y1 and Y2 demands, it's going to cycle off. If the Y2 is satisfied, the compressor's going, and still has a Y1, the compressor speed will be controlled back to the target. So you got some modulation going on. You got some dehumidification happening here. It is a great algorithm running on this. That's why I would suggest a Y1, Y2 stat. And if you can get a constant torque motor furnace or air handler or variable speed, do so. You'll get the best out of this, okay? That's where you're going to hit your 18 Seer ratings. And on a single stage stat, it's based on two stage. All the 18 Seer is based on two stage. But on a single stage, it's basically a lot like the first stage, except for it's not going to linger. You don't have that sweet spot in the middle where you got Y1 running, and then you go to Y2, and then you got 20 minutes. If you got a single stage stat, you're going to run Y1 and Y2 at Y2 fan speed after 20 minutes, regardless. Then it's going to go and work its way a half a hertz every 15 seconds to full speed. So you lose a little bit with that, and sometimes, it may not matter. It depends on what part of the country you're in. Again, if you're in a real high humidity area, that might be the case. You might, lose a little bit of dehumidification with a single stage stat, but if you can pull a 2-wire, if you can pull a 6-wire connection, more power to you. 8-wire is probably what they come in the most. I just go ahead and pull 8-wire. Well, that's how a single stage stat is going to take care of it and work. And again, it's the same style, it's the same algorithm here with a single stage stat, other than it's not going to give you that betwixt Y1 and Y2. Compressor starting speed. It's going to, and this is all for oil return, and we're going to talk about oil return algorithm in just a minute and oil return mode in just a second. But what this does is just thinking, it's go, okay, again, I've been off for 20 minutes, right? And if you're calling for me to come on at a lower percentage, no, I'm not going to do that. What I'm going to do is I'm going to run at 70% for a little while, and I'm going to make sure I got some oil back. And there's different times and everything. So let's look at some timing of oil return on this thing when it gets into the oil return mode. Again, I hate to read this, but I want to read it to make sure I get it all right. If during a call the compressor runs at max hertz for 5 continuous minutes, then it can be determined oil return has been accomplished and the algorithm will reset. So in other words, if we run at that for a long time, then okay, we're good. It's not going to put it in an oil return algorithm. If you remember when I talked about sizing this thing right, here's another catch-22. If you turn around and decide to put this thing in the 3-ton and it never runs 100% because you did, you're going to screw with this algorithm and you run the chance of not getting enough oil back quick enough back to that compressor. Okay, so don't fudge on the size. The low speed oil return threshold is 90 minutes when the ambient temperature is below 65. Again, 65 being the sweet spot. Okay, so if it's at or above 4 hour, if it's at or above 65, it's going to look at 4 hours and then it's going to try to go into a oil return algorithm as well. Again, I can't get too much deeper than that on that, but just know, and the reason I'm saying it is this: you can be sitting there running, or you can be sitting there out in the unit and working on it, or the homeowner can be sitting out here, and all of a sudden it just ramps up for no reason, and the homeowner may be confused. Some homeowners really understand their investment. They invest a lot of money into this, and they're going to sit out there, and if they're out there and by a deck or anywhere where they can hear it, and it starts ramping up, ramping down. That's why I'm telling you all these algorithms today. That's normal. Okay, that's okay. I don't have any issue with that. Start time off in 20 minutes. That's just the 70% I keep talking about. I don't want to keep running into the ground, but it also includes existing defrost. So if you happen to be into this 70% and you shut down, it's going to finish up its runtime on the next call, whether it be heat or cool. Now, the suction pressure transducer, it emulates a low pressure switch, but we do have a low pressure switch on there. If that low pressure switch opens up, the 5-strike rule, you have to kill power to this, okay? You got to kill 24. Also, make sure you kill both indoor and outdoor unit. When I say kill, shut down, that's not the best way to put it. Just phrase it a different way. But, you got to shut down both power and that'll reset it. And then you can find out what's happened, what caused that issue to happen. Now, new pressure transducer, temperature sensor codes. These are some of the things that's been changed, and some of these will be on there. So if you got an E181 suction pressure sensor problem, you're looking at under 0.25 or over 4.75 volts. That's why we're going to turn around and do a different set of classes on this and video it, so we can really get in there and show you where to check, how to check. Because checking the same way in the same spot is going to be really, really important to do. And it's also going to be important for you to get a good meter to do that. So what about if the suction pressure transducer goes into a fault? The set doesn't work. Say it failed. This is another great thing I absolutely love about this. As Ralphie May says, it's awesome. That's exactly what this is. It'll actually go into a staged mode. So it says, okay, this little bad boy has failed. I'm going to be a 2-stage unit now. So if I got a Y1 call, I'm going to be at 70%. If I get Y2, I'm going to maximum capacity. Instead of it shutting down and saying, you know what, I got a bad sensor. The heck with this, I'm just going to quit running. Let's let the homeowner get hot. No. This is going to actually put it in 2-stage. And they may notice a difference. I think the humidity is going to be a difference with this, because the way we talked about the Y1, Y2, when it's modulating, you're going to ring out more humidity. So if you take the phone call from the homeowner and it goes, it's cooling, but it's more humid than what it was. It's a lot more humid in here than what it was. You can pretty well start guessing you may see some type of transducer fault on here. So the charge mode jumper, I told you about it. Low pressure fault is ignored during this charge mode. So you don't have to worry about any of that going on with it. And it will deactivate in 60 minutes. No big deal there. That's kind of a simple thing. Defrost. The defrost on this, you can call it many things, but you've got auto defrost and max defrost. So the auto defrost, it's got a 14-minute max time. We're used to that. Our time and temp and then on-demand boards right now have that. But we do have some new algorithms in here. I'll hit a high note on here. I've only got a few slides on this. I'm not going to get into if 4.7 volts goes into 3.7 volts and Johnny Bobby Billy went to school with a headache, he's coming home. I'm not getting that deep into it. I'm not going to do that. But the maximum defrost, this is different. This is something it's going to be different for us. It might not be different. You may have worked on some mini splits and stuff like that. 19 minutes or 5 minutes of fan runtime. So this fan is going to come on. If it happens to go to max defrost, the outdoor fan motor is going to come on. And what that's intended to do is finish pulling the water off of here. Any type of steam that's built up on that fan blade that are around the shroud that can freeze, it's going to help dry that out. Because if we had to go to max defrost to do this, and you can set it in auto max defrost, but I won't explain something to you in a minute that is going to help you out to understand. Even if you got it set in auto defrost, if the situation calls for it, you can get a max. So you really need to make sure we convey that to our contractors and go, hey, if it happens to go, and they're going to tell you 20 minutes. I don't know why we got 19. I have no clue. But it can do that. I don't know why I'm sitting there doing that. It ain't like it's running. So the new algorithm, I'm just going to, you can read this if you want. Let me just put it in my words and let's see if it helps out any. You can look at this board and it's got temperatures. It comes factory set for 50 degrees termination temp, okay? You don't see a time anywhere on here, but it is going to default to 90 minutes. So when this thing comes from the factory, you set it down. Inside that board, it's got 90 minutes, okay? You don't set that. On the outside, it's got 50 up to 100 degrees. And if you notice in max defrost, it'll also allow it to go to 110 to give you 10 more degrees. So, and it's also going to do its sacrificial defrost, okay? It's going to check the delta between the outdoor air sensor and the coil sensor. So it's relying on a ton of different stuff. So it's not looking at one single point. All those numbers and everything that's encapsulated and all that, that's the part we got to keep for right now. I'm not saying we're going to hide anything from you. That's not the point. But a lot of this stuff is proprietary. And as we make sure everything's covered in patents and all this other stuff, we'll put that in service manuals, PIBs, and things of that nature. But what it does is it's really cool how this works. It's going to say, okay, I came 90 minutes and 50 degrees. And I want to show you some crazy stuff here in just a second. The middle one is what I want you to, the middle one and the bottom one is what I want you to pay attention to, okay? Let's start with the bottom one right here. And I'm going to go through a defrost scenario with you. All right. We did our sacrificial defrost. Everything's fine. All of a sudden, what happened the past week in Texas and all over the country hits. That's not going to be good enough to defrost this unit. So after 90 seconds, this thing's looking at it and goes, okay, for 90 seconds, I'm not going to worry about anything. I don't know if I need to go into a defrost after a minute or come out of a defrost in a minute and a half. Chances are I won't, but I'm not going to start counting my algorithms until 90 seconds. So if we had to, and I'm going to take and use Texas as an example right now, if we had to look at that and say, okay, it was 45 degrees in Texas, all of a sudden, boom, we're down to it is cold, okay? And this thing's going to run, it's going to go into a defrost. It's going to go, oh, wait a minute. I had to go up to a whole lot of minutes, okay? Let's say I had to hit 14, let's say I had to hit 12 minutes. So I hit 12 minutes of defrost, and it took that long, and I still didn't make, and I barely made it to 50 degrees. And then my delta T between my sensor and everything else went out, okay? Or it widened up, it didn't go out, it widened out. So what happens is that board's going to say, we're going to change, okay? I'm going to put you in 60 minutes next time. And after that 60 minutes, I want to make sure you're at 50 degrees. If you still have to go above, and you'll look at this middle one where it goes, okay, greater or less than 70 degrees, it's going to look at all that. You may have it set 50 degrees, but the delta T between your two sensors is going to take over as well too. So as complicated as this sounds, please remember This is going on behind the curtain, okay? This is nothing. You can set it and you can set this on here, but this board is also going to say, you know what? I can think my way through these algorithms. I can think my way through this defrost and make sure that I get a good clean coil. So what happens is it's going to constantly change. So a lot of times I just tell people to put it in regular defrost, auto defrost. And if it hits to where it needs to go into a max defrost, this thing will go in max defrost by itself for how many times it needs to do it until all those parameters come back down to where they were and where they need to be. If you move your temperature jumper up, you change the way it looks at the parameters. And you can put this thing in a forced defrost. And if it doesn't go into a forced defrost, then you got issues. But it's a lot like the A97 board. It forward thinks and it backwards thinks. I won't kill you with that speech again, but it does. It kind of thinks backwards and forwards. So you can set it at that, but what it's looking at is it wants to make sure, and we changed those algorithms to make sure our HSPF stayed where it needed to be. You don't want to defrost no more than you have to, but you also want to heat the house when it's cold. So that's what, in a nutshell, that's what that kind of does. So when the defrost is determined necessary, I'm going to go to the next one. This is how it actually comes out of defrost. Your coil temperature reaches or exceeds. Again, just like I just said, it can exceed that. When the compressor operates for 14 minutes, or if it's in max, it's going to be 19 minutes, or cooling service, all of a sudden, call for cooling comes on. Then it's going to go out. Troubleshooting. Last but not least, let's figure out what's going on with this bad boy if something goes wrong with it. Very simple, very easily laid out wiring diagram. I know it's probably hard to see on this. I wasn't going to go through anything, go through wires and sequence of operation and all on this. I just wanted to show you it is a very basic, nice laid out wiring diagram. There's our thermistors, not our transducers, and it tells you what range they should be in. Most of them are 10K ohms, and it tells you all this ranges and everything. All this will be in a service manual. So will this, and this gives you, again, and if you look at the very top, the H9 jumper, you got your PN1 efficiency, normal, and comfort mode. And then it's got your pressures and all out here, and then your variable. This is what your sensors and everything should be reading. This gives you a really good, okay, if it's not reading this, this is my issue, this is my problem. These are the type of things that's going to be in there, and it's going to help us troubleshoot these really well. So let's look at the heat pump cooling operation. What I want to emphasize here is if you look at the 2-ton, okay, the 2-ton's got a 48 max on here. That's as high as the hertz it's going to get if you program this to 2-ton. Although it can go up to 69 hertz in 3-ton, the board's only going to allow this to go to 48 hertz, excuse me, at 95 degrees outside. So if the contractor decides to change that, he in essence is cutting that compressor way back or way up. So look at it from going 48 to 69 at max. You're oversizing. Your humidity is going to go nuts. But all this chart here is saying is, hey, this is what I'm going to run. Make sure if your sizes are right and you're going to do stuff like that. And if no suction pressure is measured, this is the same thing what I told you. It's a little bit different chart on here. The same thing I told you about 70% of Y2. It's going to run 47 hertz. These are just charts that tell you exactly what the compressor is going to be running. Okay, I just put them in here just to show you all that's just happening behind the curtain. And the same thing here, okay? Just wanted to show you some of the information on these sensors and how they're going to work. So what I want to go through now, and we're just about done, is I want to go through a few of the codes, okay? 410 and 411, low pressure sensor, and you'll see moderate and critical. If moderate hits, then you've got some issues, you got some problems, but it's not going to shut the unit down. And you'll look over here when you go to general conditions, error handling, As this escalates up, that's when it's going to shut the unit off. That's where a lot of your 10 strike rules and everything come in. Be sure to read, make sure they look at the complete description and what has gone on. Generally, if you're like me, I'm going to look code 410, open low pressure sensor. What's going on? Well, I didn't read everything else to the side, and that's not going to help me troubleshoot this at all, especially moderate. So if I know it went to critical, then I got issues. DC high link voltage. If you look at general conditions, and if you can see it down there, a little bit different, this thing you don't want the voltage any greater than 480. We're used to like 360, 380 on the 20 Seer. This thing, because it can go up to 69, and you look at some of the hertz ratings, because it can go up to that, you can actually go that high on that. There's your power factor correction circuit I talked so much about, and I wanted to make sure everyone sees this. And again, it tells you all kinds of things, but right over here underneath error handling, in addition, it's got 10 times in an hour. If you got that much trouble, if you got 10 times in an hour that this thing tripped, you've got issues, you've got problems. And then you got the load shed event. This is the one I told you, it's minor. If you see it on the codes, just erase it. When we talked about earlier in this presentation, just erase it. And I hope I've helped everyone out a little bit. That's a kind of a high view here. I wanted to make sure that everybody took a good look at this. And if you got any questions, please feel free to email me and make sure that you send me the questions, and I'll be glad to do that. I think I'm finishing up a little bit earlier here. But that's a lot of information to throw at you in one day. So in a little bit, we'll come back on. I think Mr. Hardy's going to come on and talk for a little bit, and then we'll do the teardowns this afternoon. So with that, I thank you very much and appreciate your time.